Extrema are functions of two variables. Given a function, we want to find the relative max and the relative min. The first problem we're going to look at, we want to figure out the max and the mins just by inspection. Suppose you have this function. Suppose you have that function. You want to find out the max or min. Well, remember, when you square something, you either get 0 or positive. When you square something, you get 0 or positive. And then you add them. Well, if you added zeros, you get 0. If one of these was 0 and the other one was positive, when you add it, you get positive. Meaning 0 plus 7 is positive. 7 plus 0 is a positive number. If they're both positive and you add them, you get positive. So when you add the first two, you get 0 or positive. Then you take away 4. Right now, you're 0 or positive. You're over here. That's how much money you may have in your bank. You may have $0 or $4. Oh, or more. 0 or more. And then something happens. You lose $4. Maybe you knew you had $0 or above in your bank account. And your mate, your spouse, goes and takes out $4. If you had 0, well, now you're a negative 4. If you're right here, when you take away, so you're right there. Let's do it in a different color. If you're right here, and you take away 4, you end here. If you were here, you take away 4, you here. If you were way out here, you take away 4, you end up here. That is, you are now going to be from negative 4 or above. If you're 0 or positive and you take away 4, you will be negative 4 or above. You used to be 0 or above, now you're negative 4 or above. That means the min of f of xy is 4. That's the least it will be. And you need to be mathematically mature enough to just see that. But if you preferred, and you really shouldn't, you could take the partials and see where they equal 0. The first partial will be 2 times x plus 1. And this equals 0 when x is negative 1. And f sub y will be 2 times y minus 3. This equals 0 when y is 3. So our critical point is negative 1, 3. And f of negative 1, 3, if you work it out, you'll have negative 4. Now, of course you're going to get 4 at, well, we made this the least it can be 0. That happens when x is negative 1. And we made this the least it can be, namely 0. That happens when y is 3. After all, 3 minus 3 is 0. When you square it, you get 0. Okay, so a negative 1, 3, that's the max. Excuse me, the min. And even the calculus showed that. We found our critical point, we evaluated it, we got negative 4. You really should be able to do it, finding that min, without doing any calculus at all. Just come and say, yep, that's what it is. Now, suppose you were asked to find the max and relative maxes and relative mins of this equation. I don't know why I didn't write it, but I meant to write f of xy. F of xy. This is where we use the D formula. D is equal to ffx at the critical point times fyy at the critical point minus the mixed partial at the critical point squared. So fx, this is a function of x, its derivative is 4x. This is a function of x, the derivative is 2y. Because 2 times y is the constant. This is a function of x, derivative is 2. This is 2 times 2x plus y plus 1. And while we're at it, let's do fxx. Partial of that is 4. These partials are both 0. Okay. So we have one of the answers 4. It's at the critical value, but it's a constant. Even if I knew the critical values, this is still 4. Okay, f, y. Constant, this is a function of y. The derivative is 2x. This is a function of y. The derivative is 2y. This is 2 times x plus y. And the double mixture, or the fyy is 2. Partial of this is 0. Partial of that is 2. So I have the second one. Let's find fxy. So first we find fx, which is right here, and then we take the partial of that with respect to y. That's the constant. The partial of 2y is 2, plus that's the constant. It's just 2, minus 2 squared. So we have 8 minus 4, which is 4, which is positive. And since, okay, it's positive, now we need to find, so now we know we have a max or a min, we just don't know which one, nor do we know the point. We need to set the partials equal to 0. If 2 times this is 0, then this must be 0. It surely isn't the 2 that equals 0. So 2x plus y plus 1 is 0. But the plus 1 I'm going to bring to the other side. If 2 times this is 0, then this is 0. X plus y is 0. If I just subtract, 2x minus x is x, y minus y is 0, negative 1 minus 0 is negative 1. So I should have what x is. X is negative 1. Now I know if I add on y, I'll get 0. Well, if you add 1, you get 0. So y is 1. So the critical point is negative 1, 1. So I just need to find out what fx equals. At this critical point. Actually, it's the double one. I need to find out what this is at the critical point. Since it's greater than 0, since d is bigger than 0, if d is less than 0, then what does that tell you, d is less than 0? If d is less than 0, there's a saddle point. If d equals 0, the test didn't give you any information. If d is bigger than 0, you have to look at fxx. Since d was bigger than 0 and fx x is bigger than 0, that implies we have a min at negative 1, 1. If you want to know what that min is, plug it in. Plug in negative 1 and 1 and negative 1 and 1 and negative 1 and work it out. You'll get your answer. But I guarantee you, we have a min at negative 1, 1. Suppose you have that c is equal to 2x squared plus 3y squared minus 4x minus 12y minus 13. Find the relative extremes. Find the relative maxes, relative mins, and saddle points. The saddle point when d is less than 0. Okay, so z sub x. This is a function of x. Its partial is 4x minus 4. This 4 times x minus 1. This equals 0 when x is 1. Okay, z sub y. Here's a function of y. The partial is 6y. Here's another function of y. The partial is negative 12. This is 6 times y minus 2. And this is equal to 0 when y is 2. Sometimes this will be a function of x and y. Like, I don't know. Well, yeah, like the last time. And dy can be a function of y. And then you have to solve them simultaneously. So the critical point is x equals 1, y is equal to 2. Okay, now we need to prepare for the d-test. We need to find zxx. The partial of this is 4 with respect to x. The partial of that constant is nothing, 0. 4 minus 0 is 4. The partial of zy, I'm taking the partial of zy. This partial is 6. This is 0. It's 6. Now we need to find the mixed partial. I go to zx, and I take the partial of that with respect to y. But there are no y's. It's 0. So now d, and then I find this at the point 1, 2. But it's constant. I find this at the point 1, 2, but it's constant. Same here. So you have 4 times 6 minus 0 squared, which is 24, which is bigger than 0. Now I look for zxx, which is 4. It says so. It's 4, which is bigger than 0. This implies that we have a min, a relative min at our critical point. Sometimes it might get more than one critical point. Test one by one. Do the d-test for the first critical point, get your answer, then do the d-test for the next critical point. For example, if z sub x was x squared minus 1. Well, this equals 0 when x squared is 1, which means x can be plus or minus 1. So there's a reason why you might get more than one x value. And if zy was just y, so then it equals 0 when y is 0. So the critical points will be plus 1, 0, and negative 1, 0. So you can easily get more than one solution. It might be that z sub x is a circle. and z sub y is a parabola. And what do you know? They meet in 2 points. It could have been a line. They meet in 2 points. It can be a circle and a line that don't meet. It can be a circle and a parabola that don't meet. Okay? It can be a circle and an ellipse. And they can meet in 4 places. There's definitely cases where you get more than one critical point. So let's consider this next problem. Suppose that z was equal to e to the negative x sine of y. Well, then z sub x would be negative e to the negative x times the constant. Z sub y would be the constant times the derivative of the function of y. Now, the thing is, so we have a product here. It's this times that. Now, this times that. This is e to the x and never equals 0. This is the graph of e to the negative x. It too never equals 0. Okay, so if this equals 0, that implies that the sine of y must be 0. Because it isn't this that's 0, so it must be that. If not this is 0, so it must be that cosine of y is 0. Now each of these have solutions, but not both of them together. The sine, you should definitely know this. Whenever the sine is plus or minus 1, the cosines are 0. When the sine is 1, the cosine is 0. When the sine is negative 1, the cosine is 0. You're not going to believe this, but when the cosine is 1, the sine was 0. When the cosine is negative 1, the sine is 0. When the cosine is 1, the sine is 0. They're never, ever, ever 0 at the same time. No solution, which implies no critical points. Graph doesn't have any critical points. Wouldn't mind seeing what it looks like personally. It has no critical points. It's basically, I'm not saying it looks like this, but here's e to the x. It doesn't have any critical points because the derivative is e to the x, and like I said, it doesn't ever equal 0. Well, if I just make this 3-dimensional, if you have something that looks like this, of course it goes out this way forever, and it goes out this way tangential. But you see the curve. You see the curve. Okay, that's not going to have any max or mins. It goes up forever, and it doesn't ever reach its lowest point. So we try another one. This time, they're telling us the critical point is at x0, y0. They tell us that. They're like, here it is, Happy New Year. And they also tell us fxx at the critical point is 9, and fyy at this special point is 4, fxy at the critical point, this is 6. They ask us to tell us what's going on at x0, y0. Is it a max? Is it a min? Is the test going to fail? Well, since this is greater than 0, we might have a min. So we have to find a d value. D is fxx times fyy minus fxy squared. 36 minus 36 is 0, implies that we don't have enough information. Insufficient information. We can't tell. They didn't give us, the test failed. I mean, that's what it tells us. The test failed. If D is 0, the test fails. I always wondered why in the ratio test and the root test, they'll say the test failed. But they don't say that here. Every textbook I've ever seen, they always say insufficient information. The test failed. Okay, what if we have another test, which means we're given different values right there. Those values, they're no longer 9, 4, and 6, but rather -9, 6, and 10. -9, 6, and 10. And since fxx is negative, if D is positive, then you get an answer, max or min. If D is positive, then if this is negative, you have a max. If fxx is positive and D is positive, you have a min. Well, it's -9 times fyy, which is 6, which is negative, minus 10 squared. This is -54 minus 100. This is less than 0. That implies that we have a saddle point at x0, y0. We have a saddle point. The next problem asks us to find the absolute extrema of the function over the region arm. Absolute extrema means max or min. It means the extremes. You ask somebody, you ask the professor, in the last exams, what was the extreme grades? Teacher will say something like 20 and 103. Lowest grade was 20, with extra credit, somebody managed to get 103. Now, suppose, this is a long, tedious problem, unfortunately. Suppose you have this surface, and the region R that we're allowed to be in is the point within this triangular region. It's within this triangular region. It's within that triangular region. X, Y. 0, 1 is right here. 2, 0 is right here. And 1, 2 is right here. That is, you can only take f of points in this triangular region. You can only take f of points in this triangular region. This point is 1, 2. This is 2, 0. And this is 0, 1. Let me call this line 1, and this line 2, and this line 3. Now I can look at points on 2 points in a line and just rattle off the equation. The equation of line 1 is going to be negative a half x plus 1. Okay, you have 2 points. You have 2 points. Find the equation. Now, with respect to this line, x is going between 0 and 2. Over here, x is 0, and here, x is 2, and in between, x is between 1 and 2, 0 and 2. So, with respect to line 1, x is between 0 and 2. That is important. Now, line 2. Oh, this one I can just see. There's x, the y value is 1 bigger. There's x, the y value is 1 bigger. If it happens where both points, that's the formula. The y value is 1 more than x. And for this line here, x's go between just 0 and 1. Here it's 0, and up there it's 1. X is between, that's the formula for x is between. That's the symbol. It's between 0 and 1. Okay, line 3, 1, 2 to 2, 0. That is going to be negative 2x plus 4. And x goes between 1 and 2. The x value up here is 1, down here is 2. X is going between 1 and 2. Okay. What we're going to do is, so it turns out that, I just want to see what we want to do with this problem. Okay, so we want to find the max and the min. I assure you that maxes and mins on lines, if the borders are lines, is going to happen. The max or mins for the top equation, f of xy equals 12 minus 3x minus 2y, will happen, will occur on the line. It will occur somewhere on the line. If I remember correctly, it will even happen at the endpoints. Okay. So, from line 1, f of xy, that's y. Y gets replaced with a half x plus 1. So I get 12 minus 3x minus 2 times y, half x plus 1. So this is 12 minus 3x plus 1, 1x, excuse me, minus 2. 12 minus 2 is 10, minus 2x. And x fluctuates between 0 and 2. X is between 0 and 2. Okay, so now, what's the max? What's the min? Well, if you want this to be the most, you want to take away the little. You want to take away the least. Let x be 0. You have a max when x is 0. And y, well, y is 1. Negative a half times 0 is 0, plus 1 is 1. You have a max at 0, 1. Y equals 1. And the z value, the max value is 10. The max value is 10. The min value, 10 minus 2x, and x is in between 0 and 2. You want to make this the least? Take away the most. Let x be 2. X is 2. And z is 10 minus 4 is 6. I could have gone 10 minus 2 zeros is 10. Okay, and when x is 2, the y value is 0. So you have a max at 2, 0, and that min at 2, 0, and the min is 6. So let's keep this information up here. From line 1, you have a max at 0, 1, 10. The z value is the max. And you have a min at 206. That's from line 1. And we're just going to go through all the lines and see which one gives us the max. Which one gives us the largest of the maxes. Which one gives us the least of the maxes, of the mins. That will be the min. Okay. Line 2. Y is x plus 1. So f of x comma x plus 1. This is 12 minus 3x's minus 2y's, which is x plus 1. So you have 12 minus 3x minus 2x minus 2. 12 minus 2 is 10 minus 5x's. And for line 2, x goes between 0 and 1. So what's the most? Well, you want to take away the least. Let x be 0. X is 0, y is 1 more, and the max will be 10 minus 0, or 10. The min. You want to take away the most. Well, let x be the biggest it can be. Let x be 1. And y is 1 more. And f will be 10 minus 5 times 1. 10 minus 5 is 5. So the min is 5, the max is 10. This is the information from line 2. You have a max at 0, 1, and the max is 10. And you have, so the maxes so far were the same. They're both 10. You have a min at 1, 2, 5. In line 1, the min was 6, but in line 2, we got a min smaller. It is now 5. Okay, we do it for one more line, and we look at our results, and we'll be done. Okay, line number 3. Line number 3. Y is negative 2x plus 4. So f of x comma y. But for right now, y is 2x plus 4. So it's 12 minus 3x minus 2 times negative 2x plus 4. is 12 minus 3x plus 4x minus 8. 12 minus 8 is 4. If you take away 3 x's and you add x, you get plus x. And x fluctuates between 1 and 2. If you want the min, 4 plus the least will give you the min. So x is 1 and y is negative 2 times 1 plus 4. Y is 2 and the min is 5. Now the max is going to be 6. Let x be the most. Let x be 2. Then y is 0 and 4 plus 2 is 6. I just substitute in 2 for x. That's the max. So when it comes to line number 3, we have our max at 206 and we have a min at 125. That's the results from line 3. Now we're ready to put this all together. I don't think this is a hard problem at all, but it took a while. The min is 5, the min is 5, the min is 6, okay? The min is 5. Min is 5, and it happened that they both say 1, 2, 5. 1, 2, 5. You have a max. The max equals, well, here's the max is 6. Here it's 10. That's bigger. And here it's 10. So the max is 10. And, well, they were both the same points. 0, 1, 10. 0, 1, 10. If you prefer, you don't have to plug in the z value. But it really should be there. But if you didn't, everyone would understand the max is 10, and it happens when x is 0 and y is 1. Because 0, 1 means x is 0, y is 1. Okay, that completes that problem. I hope you all understood this one. If you didn't, there's a button on your computer that's called rewind. Use it, please. Yes, I felt that was an important problem to see. Let us try one more. Won't be as long, but very similar. Suppose you're given a function f of xy is equal to 3x squared plus 2y squared minus 4y, and the region is bounded by y equals x squared and y equals 4. So here is y equals x squared, and here is y equals 4. So it's everything bounded. It's everything that I didn't erase. But it's not the x nor the y-axis. It's everything in this figure right there. Okay. Just keep in mind that's negative 2, 4, and this is 2, 4. Alright, so now we have to figure out what the max is. So again, the max is going to be on the boundary. It's either going to be along here or it's going to be along here. Okay. So how about this one? So we need to figure out what f of x comma y is. So y is x squared. So it's 3x squared plus 2 times. Now y is x squared. When you square it, you get x to the 4. Minus 4x squared. So you get 2x to the 4, combining these two, minus x squared. Now this is just a Calc 1 problem to find the max and the min. Call this f of x. Well, then f prime of x is 8x cubed minus 2x, which is 2x times 4x squared minus 1. I can factor that to 2x plus 1, 2x minus 1. This equals 0 when, well, 2 is never 0. X is 0 when x is 0. X is 0 here when x is negative a half. And x is 0 here when x is plus a half. We'll get plus minus a half. Okay. So we need to check f for 0 comma y is 0 squared. So f for 0, 0. We need to try f of, now whether you have plus a half or negative a half, when you square it, y is a quarter. We need to investigate those 2 points. Actually, those 3 points. And depending upon the odd evenness of our graph, we may have to separate it and do it twice. One for plus a half or quarter, and one's to find negative a quarter, negative a half comma a quarter. But for right now, I'll write it down like that. So that's what happened along y equals x squared. Now what happens along y equals 4? If y is 4, well then y is 4. So we need to find out what f of x comma y is. Well, y is 4. So you get 3x squared plus 4 squared is 16 times 2, 32 minus 4 times 4 is 16. So we get 3x squared minus 16. And I should point out that x is between negative 2 and 2. I should have mentioned that in the last case that all our x values are actually in between negative 2 and 2. Okay, well now this here is a parabola. It's a parabola that mins out at 16, negative 16. It goes like that. So what's going to happen is, and it doesn't matter where 2 is. If 2 is here, then that's the max value, because you only have this. If 2 is here, well then that's the max value, and of course that one. So we know we're going to have a max value at the 2's. So f of plus minus 2, and y is 4. Those are the places we're going to look for. No, I don't like what I just said. Yeah, you have to check the endpoints. You have to check the endpoints. Okay, and in the last case, it was f of x comma x squared, and if I let x be the endpoints, when I square them, I always get 4, and that one we're looking at. But what I did mess up on is we're going to have a min right there. We're going to have a min at when x is 0. And of course, y is 4. You might have a min right there. Yeah. Okay. So we just need to check, oops, I can bring that back. We just need to check f of these handful of points. And we'll find the max and the min. The largest f value or z value will be the max and the least will be the min. So f of 0, 4. 0, 16 times 2 is 32, minus 16 is 16. Okay, so we did this one. Now, we're always squaring the x's, so it doesn't matter whether, we don't have to do the plus minus 2 separately. You square plus minus 2, you get 4. You triple it, you get 12, plus the rest happen to just be this. Plus 16, 28. Okay. F for 0, 0 will be 0. Now we have to do f of plus minus a half, comma, a quarter. You square a half, you get a quarter. You square plus minus a half, you get a quarter. Times it by 3, you get 3/4, plus 2 times a quarter squared. That's a half times a quarter, which is an eighth. Now 4 minus 4 times a quarter is 1. So what I want to do is get everything with an 8 on the bottom. 3 out of 4 is 6 out of 8. 1 out of 8 is 1 out of 8. And 1 is minus is 8 out of 8. This gives me negative an eighth. Okay, so now I look at my z values. This is the min, and it happened at plus minus a half, comma, a quarter. That's the max. You have a max, and this happened at plus minus 2, comma, 4. The max is 28. The min is negative 1/8. Okay, you have to check the endpoints, because the endpoint can be a max, but the slope of the tangent line doesn't have to be 0. It's only a max because you're saying stop right here. Otherwise, it wouldn't have been. If you have a curve that goes like that, you're going to have a max here. But if you say start here and finish right there, this is your graph. Well, you know what? You have a max right here. And the slope of the tangent line is in 0. And then you definitely have a min right here. So, you know, if we stop the graph, right here. We stopped right here and right there. It's only in between. Well, the max and mins are actually on the endpoints. You have to check your endpoints. Alright, we're just going to do one more. Suppose you were told that f of xy is x squared plus xy. And the region is the absolute value of x is less than 2, and the absolute value of y is less than or equal to 1. Now we have to translate this. This means that x is in between negative 2 and 2, and this means that y is in between negative 1 and 1. It's this square right here. It's that square right there. Here is 2 and negative 2 and 1 and negative 1. All these points inside that square and on the square. All the points on the square and inside the square. Every one of those points, they have one thing in common. The x values between negative 2 and 2, and the y values in between negative 1 and 1. So we want to find the absolute extremes. Okay, so we need to know the equation. The equation of this line is x equals 2. This line, x equals negative 2. This line, all the y values are 1. Up here, positive 1. So, along y equals 1, we know that f of x1 is x squared plus x. And if x, and we also know that x fluctuates between negative 1 and 1. And we can take the derivative. This is 2x plus 1. It equals 0 when x is equal to negative a half. Okay, so what we need to do is, and I'll keep the bookkeeping over here, we need to check f of negative a half, and y is 1. We need to check the endpoints. Negative 1 for x, and 1 for y. 1 for x, 1 for y. X is changing, y is constant. So we need to check those. And I suspect we're going to get some more. Now so y equals 1. So I've done this line. I've done that line. Now, what if y is negative 1? Suppose y is negative 1. Y is equal to negative 1. The f of x, y is negative 1. This will be x squared minus x. The f prime of x is 2x minus 1. And this equals 0 when x is a half. And x can go between negative 1 and 1, and a half is in between there. So we need to check f of a half, comma, y is negative 1. And the endpoints. We need to check f of negative 1, and y is negative 1. And we need to check f of 1, the right endpoint, and our y is negative 1. We checked. Why is y negative 1? Okay. Something's a bit wrong. X goes between negative 2 and 2. X goes between negative 2 and 2. Which means we should have been doing that. Between negative 2 is one endpoint, negative 2, negative 1 is one endpoint, and 2, negative 1 is the other. Same thing with their top line in red. X could have gone from 2 to negative 2. Positive 2, 1, negative 2, 1. The endpoints. Okay, we just talked about that line. Now we let x equal 2 and then negative 2. X is equal to 2, and y now goes between negative 1 and 1. So f of x, which is 2, y. This gives me 2 squared plus 2y. Now this is a line, or line, and it has a slope. It has a non-zero slope. it has a max at one of the endpoints. Now I can take the derivative f prime of y is 2, which is never 0. So I just need to find the endpoints, f of the endpoints. X is always 2, and y is -1 or 1. Which, by the way, I do not have. Well, I have one of them. I have that one. But okay, I have it. So now x was 2. That was this line. Now we need to look to see what happens when x is -2. Now, x is -2. And y goes between -1 and 1. So f of x, y is 4 minus 2y. And again, it's going to happen at an endpoint. I want you to think about why that's going to be true. So we do f of x is -2 and y can be 1, or y can be -1. In fact, I'm not even going to bother to work out what I have in the bottom here. Minus some duplications, for example, this one here is the same as that one. -2, -1, or f of that is the same as that one. I have two -1s right next to one another. 2, 1 is over here. So I need to check 1, 2, 3, 4. You check those 4, whichever one gives you the largest value, that's the max. Whichever one gives you the least value, that's the min. And of course, you're using this rule right there. Okay, that finishes up the section entitled Extreme is a function of 2 variables. Good luck with them.